Hello guys, today we're going to study system of linear equations in 3 variables, okay? If you look at this example 1, it's very similar to the type of question we have done in previous session. So that's why I already plug in everything, okay? If the question is showed that the order table we have -1 to -2 is the solution of the system. So all you have to do is label this as your x and y, z, and then plug it inside your equation 1, 2, and 3 and see if it's going to be true statement or is a false statement. In this case, if you look, that's -1 plus 4, that's +3, and then plus 6, that is 9. So that's why you have this is true. You're doing the same thing for the rest of them. And make sure all of them must be truth. Then we say, therefore, the ordered table is the solution of the system. Okay, that is example 1. Example 2, solving a system in 3 variables. So here, the idea for this type of question, okay, so what you're going to do is you're trying to use 2 equations and then eliminate a variable, okay, then use other 2 equations to eliminate the same variable, okay. So let me go ahead. We're just going to start with using the equation 1 and 2. Okay, all I did is rewrite this, and then we look for equation 1. So the easiest way for us to get rid of, you could get rid of any letters, all right, any variable, but in this case I see this 2z. If I multiply equation 2 by 2, then we're going to have 4z, and then we have -4z, so they're going to be gone. So that's why this is no change. And then here, we're going to multiply every single term. Now we're going to add them together. So that will be 11x, then plus 4y. This is going to be gone. We're going to have -3. So that is my equation 4. Okay, we're eliminate the same letter z. So now I'm going to use equation 2 and 3. So I'm going to rewrite this. Okay, for equation 2 and equation 3, we want to get rid of z. So I'm just going to go ahead and multiply this equation 2 by -3 and then multiply equation 3 by +2, because then I'm going to know this is -6z, and then that will be plus 6z, and then they're going to be gone if I add them together. So there's a whole thing to give us. So we're going to add them together. So it gave you -13x. Then plus y, and then here it's going to be gone, and then we have a 15. So now we have equation 4 and 5. We can use these 2 equations, create a new system with 2 variables. So once we write them together, so we can solve this by any method. So by now, I assume everybody know how to solve this. I'm just go ahead rewrite this. Okay, then we're going to solve this by the substitution. So I'm going to bring this back to equation 4. So I'm going to have 11x plus 4 times 13x plus 15, and then equal to -3. Okay, all I'm doing is just a substitution. So you solve this, you get x equals -1. And then you do a substitution, you put this in here, that will be y equal to 13 times -3 and then plus 15. And then you're going to get +2. Okay, once we have your x and y, so we can plug this back inside your equation 1, 2, or 3 to find your z. Okay, so all I did is just rewrite the equation 1 since it's a little bit far away from us. So I'm going to plug in 5 times my x was -1, and then 2 minus 2 multiply 2 minus 4z, and then we're going to simplify this. -5 minus 4, that's -9. Okay, go to another side, become +12, then z equals -3. Then the solution is -1, 2, and -3. Okay, be careful when you write the solution, you must write the order x and y, z order. We have another system. In this case, we can already use equation 1, right? Because equation 1, we don't have y. So I can actually using equation 1. So then what we're going to do is we're going to use equation 2 and 3 and get rid of y. Okay, this time I'll be a little bit lazy, so I'm just going to not recopy this whole thing. So from equation 2, okay, I want to get rid of y, so I can multiply this by using -2. Okay, and then we're gonna have, and then for equation 3, there's no change. Then we're gonna add them. You're gonna have -x, and then that will be -3z, and then here we have -18. Okay, that is our equation 4. So because we said we can use these two equations, we can use equation 1 and equation 4 to create this system with two variables. So I'm just going to write them together. So you can solve this by any method, but if you look, we could just add them together because then we can just get rid of x. Okay, whatever the method you prefer, that's fine with me. So this is going to be -2z, and then you add them, that -10, and then that means z is just going to be +5. So once we find this, you can bring this back here, and then I can find that x plus 5 equals 8. X is just going to be 3. Okay, now we have our x and z, so we're just going to sub this back. All right, we're going to sub this back to equation 2, then we can find our y. So that will be x. So that will be x plus y plus 2z equals 17. So we're going to plug in 3 plus y plus 2 times z, which is 5, give me 17. And this the whole thing. I simplified it. 3 plus 10, that's 13. Subtract that both sides. I'm going to have y equal to 4. Okay, so then I can write the solution is, always write the x and y z order. So our x is 3, and then y is 4, and z is 5. So that is how to solve this type of question. Okay, let's look at example 4. Example 4 is finding the quadratic function y equals ax squared plus bx plus c, whose graph passes through the given points. We have these 3 points. Okay, I already labeled this for you guys. So when you have 3 points, just thinking you have a 3 ordered pair. Okay, all you have to do, the idea is you're just going to plug it inside here. All right, x, that yellow color is your x, and then the blue color is your y. So you're just going to plug it in. So if I'm going to plug in, I'm just going to write it down. So basically you're just doing substitution. So you're going to have the blue color, that will be -7, and the a times the yellow color is 1 square, and then plus b times 1 again, and plus c. Okay, all you're doing is a substitution. Okay, and then we're for the second, okay, the second ordered pair. So we have -3 and -35. You do again, here your y is -35, and then the a times, okay, your x -3 is a square again, and b times, okay, again your x is -3, and then plus c. You're doing the same thing for your third ordered pair. So I'm just go ahead and write it down. Here I just did a color coding, so all you have to do is to plug them in. So now I'm going to clean it up a little bit. I'm going to simplify this. It's going to become a plus b plus c equals -7. And then the second equation, that will be 9a minus 3b and plus c equal to -35. And then we have the last one, that will be 4a minus 2b plus c equals -19. So now we're going to have these 3 variables. Instead of we're using x and y, z, we're just going to have a, b, c. Okay, the method is exactly the same. You're going to solve this. So I can do it probably pretty quick. For this, the easiest way, we're just going to use equation 1 and 2. Okay, I'm going to multiply this equation 1 by -1. Then I'm going to have -a, -b, and -c equal to +7. And then the second one, where I'm not going to change anything. So then we're going to add those together, which we have been doing. That will be 8a, and then minus 4b, and then the c is going to be gone. And then that give you -28. Okay, And then we're going to go ahead and use equation 2 and 3. Okay, equation 3, I can also multiply by -1 to give rid of c. So this is going to become -4a minus, not minus, plus 2b minus c, and then equal to positive 19. Okay, we're using the equation 2 again, no change. I'm just going to be a little bit lazy, so I'm just going to copy it right here. That will be 9a minus 3b plus c equal to -35. So we're going to add them together. So that will be 5a, all right, minus b, going to be gone. And this is going to give you -16. So that will be our equation 4, and then here we have equation 5. Once we have this, because we said we have been doing this, that will be my new equation. I'm going to make a system now. There's all different ways to solve this, alright? You could reduce this equation 4, divide by every single term, divide by 4, okay, reduce a little bit, you can do that. And you can use whatever the method you want to use. That really doesn't matter. So I'm going to rewrite the equation 5 as b equal to 5a plus 16. Okay, then I'm going to do a substitution. So I'm going to substitute this. So I'm going to have 8a minus 4 times 5a plus 16 equals -28. Then you get a equal to -3. Okay, you get a equals -3, and then you do a sub back here, you get your b. I'm just going to write here b equals 5 times a, all right, plus 16. That's just going to be 1, so that's your b. So then you plug this ab back to equation 1. We're going to have, all right, a is -3, and then b is 1, and c is, we do not know. So then we solve this. We're going to have -2. Okay, c just going to give us -5. Okay, we find our ABC. Just the same thing you did for x, y, z. All right. So remember the question's asking you. Okay, go back to the question. They're not asking you to find your ABC. They're asking you to find the quadratic function in the form of y equal to ax squared plus bx plus c. Okay, so here is what you have to do. Once you find your ABC, so I'm going to copy this down. We're going to have a y equal to ax squared plus bx plus c. This is the one they want you to write. So I'm just going to plug in our ABC. Our a is -3, b is 1, and then c is -5. So then I'm going to clean up a little bit. That will be y equal to -3x squared plus x minus 5. So that is our final solution. In the end, you just have to do a substitution. So then y equals -3x squared plus x minus 5 is the quadratic function that passes through these 3 points. Okay, let's look at this example 4 again. So you plug in your 3 ordered pair. Okay, once you plug it in, and then you rewrite this as a system with 3 variables. Instead of using x and y, z, you're going to use a, b, c, and then you just solve it whatever the method you prefer. Once you solve it your a, b, c, and then you have to plug back inside this quadratic function form, and then write your final answer. Okay, so that is our example 4. So thank you for watching the video. I'll see you guys in the classroom.